After graphing exponential functions, it's also important to be able to solve them. The 3 steps for solving exponential functions, including isolating the a to the x portion, making the bases on both sides of the equal sign match, and then equating the exponents to solve. As an example, consider 25 to the x minus 125 equals 0. Our first goal is to isolate the a to the x term. So I'm going to add 125 to both sides, leaving me with 25 to the x equals 125. Now I want to be able to equate my bases. To do that, I need to find some base that I can raise to a power and then be able to equate my exponents. When I do that, I see that I can rewrite 25 as 5 squared, and I can rewrite 125 as 5 cubed. Remembering our rules of exponents, I can change this to 5 to the 2x equals 5 cubed. And now, since my bases are equal, my exponents are also equal, leaving me with x is equal to 3/2. As a second example, consider something like 8 to the y minus 1 equals 1/2. As an important note, negative exponents will usually help with fractions. For example, on this one, step 1 to isolate the a to the x term is already done, so I need to equate my bases. I can rewrite 8 as 2 to the 3rd power, and I can rewrite 1/2 as 2 to the negative 1st power. Using my rules of exponents here, I get 2 to the 3y minus 3 by distributing is equal to 2 to the negative 1. If my bases are equal, my exponents must also be equal, leaving me with 3y minus 3 equals negative 1. Adding 3 to both sides, I get 3y equals 2, or y equals 2/3. For the next example I want to show you, let's consider something like 2/3 to the x equals 9/4. Notice here, it doesn't seem that our bases are going to be able to match, but consider that we could flip this fraction and make it to a negative 1 power, and now we can get our bases to match by making this 2/3 squared to the negative 1. Since our bases match, our exponents must match, leaving us with x equals negative 2.